we're given y equals x squared minus 4x, and the question reads, find the area under the graph on the indicated interval. So the indicated interval for this function is -4, -2. We know now that the area is the limit of the Riemann sum, but that will be complicated for us, especially in this class, to determine the limit of the Riemann sum. But it's not going to be difficult to determine the integral from -4 to -2 from x squared minus 4x dx. So remember, this is dy. Function base times height. Okay, so now we have, according to the fundamental theorem of calculus, we will determine the most general antiderivative. And we know that this is x cubed over 3 minus 4x squared over 2 from -4 to -2. Okay, I can simplify a little bit, like x cubed over 3 minus 2x squared from -4 to -2. I have to evaluate this function with -2 in it, so it will be -8 over 3. So this will be 4 times 2 is -8. But minus, and I prefer putting parentheses in case I forget to distribute the negative sign. When I plug in -4, I have -64. Correct my numbers anytime, because I'm lazy with the calculator. And minus 4 squared is 16. 16 times 2 is 32. Okay. So when I plug in -2, and then 4, that's correct, and then minus outside, and then I plug in -4, I think that's correct, and then 16 times, yeah, I think I'm okay so far. Okay, so this is -8 thirds minus 8, and then plus, as you see, 64 over 3, and also plus 32. Okay, 64 minus 8, because they're both on top of 3. So I think that this is 56 divided by 3. And then 32 minus 8 is 24. Okay, now the least common denominator is 3, and this one needs to be multiplied by 3. Okay, I'm lazy now. 56 plus 3 times 24. 128. So this is the area under the graph of x squared minus 4x between -4 and -2. Do you feel like determining more areas, or is this okay?
I have one question.
Please.
So where you began from a equals s of -2
The integral between -4 and -2 from x squared minus 4x dx. Yes.
So on top, is it always going to be the lesser number on top of the integral?
Very good question. This is the bigger than -2. So -4 is smaller than -2. So between -4 and -2, this is the smaller and this is the higher.
Okay.
However, it's a perfect question, and I want to answer more to it. The integral, this is one of the properties that I have to present today anyway. The integral from a to b from f of x dx, it doesn't matter, the order is not important. I have to use what I'm given. It's the same with the opposite from b to a from f of x dx. So this is one of the properties of definite integrals. So if you, at any point in time, if you feel that you should switch this, you can, but remember to put a minus in front. And the answer will be the same. Very good question. Thank you.
Can you do 32?
Yes, 32. Very good. Same page?
Yeah, it's on 401.
Very good. 32.
Or
is that okay?
Yeah, it's fine.
2x plus 1 over x on the interval 1, 4. I said that, but I just want to re-emphasize. The function, I didn't remind you of that because it's a polynomial function. But if the function is not continuous on this interval, this fails. I cannot determine the area in this way. But this is a continuous function everywhere. Now, for this, I'm going to say, is this continuous everywhere on one? Yes, it is, because this is the only problem, but 0 is not in the interval. So in order to determine the exact area, I have the integral from 1 to 4 from f of x dx. You can write it if you'd like, if you feel like it. Switch this in different order if you want, the opposite order, but you have to put a minus in front. So now I have to find the antiderivative of 2x. 2x squared over 2. What is the antiderivative of 1 over x? And I hope you looked at what we did last time. From 1 to 4. The derivative of natural log x is 1 over x. The derivative of 2x squared over 2 is 2x. Now, I continue by plugging everywhere 4. Of course, I'll simplify this. So I have 16 plus natural log 4. I can drop the absolute value symbol because 4 is a positive number. Minus, when I plug in 1, I get 1. When I plug in 1, I get 0. So this is 16 minus 1, which is 15 plus natural log 4. This is the area. If you want to approximate, you can. Very good pick. And I just realized that I copied the problem incorrectly. Keep an eye on that. So let's do it one more time. This is perfect. Everything is fine. I just didn't see the power. It's a perfect exercise. So let's do this again. It's a different area. Of course, it's a different function. The integral from 1 to 4 from f of x dx. Same thing. 2x squared over 2 minus 1 over x. I want to remind you that when we differentiate 1 over x, we get negative 1 over x squared. When we integrate 1 over x squared dx, we get negative 1 over x. So we've been using this for a while. Okay, so I haven't finished. I have to plug in 4 and subtract when I plug in 1. So, of course, these two go away. So when I plug in 4, I have 16 minus 1 over 4 minus. When I plug in 1, I have 1 minus 1. Oh, nice. So then I have 64 minus 1, 63 over 4. Very good pick. Thank you. Let's move on to page 402. Okay, let's also look at some integrals if you'd like to choose from 43 through 58 on 402. If not, I will. Any preference? Okay, I will choose 54. This is the integral from a to b from negative e to t dt. One of the properties of the integral, the definite integral, is the same with the property for the summation notation. Any factor in front can be moved in front of the integral. So I can move -1 outside. A to b, e to t dt. Which function prime is e to t? Well, that's the nicest function, is e to t. Of course, minus in front, I have to copy it, from a to b. So I plug in b and I get e to b, minus when I plug in a, I get e to a. Yes, you can distribute a negative sign now, negative e to b plus e to a. Okay, I'd like to illustrate with a word problem. Like, let's say from physics, 80 on 403. A particle is released during an experiment. Its speed t minutes after release is given by v of t equals -0.3 t squared plus 9t, where v of t is in kilometers per minute. Kilometers per minute, and t is in minutes. Okay. How fast does the particle travel during the first 10 minutes? So we have the velocity. So v of 10. Let's see if I need, so this is 100 times this is -30 and plus 90. So this is 60 kilometers per minute. Okay. Okay, so actually we're asked to find how far does it travel? Okay, it's a different story. So the distance is the integral from 0 to 10 from v of t dt. So the integral from 0 to 10 from the function -0.3 t squared plus 9t dt. How do we know? It's simply because the distance is the antiderivative of the velocity. But we are also asked to evaluate it. So -0.3 t squared, so I need t cubed over 3, plus 9 t squared over 2 from 0 to 10. Luckily, I only need to plug in 10, because when I plug in 0, everything is 0. So when I plug in 10, let's see what we get. This will be -0.1, and this will be 1,000, and this will be 4.5, and this will be 100. So this is going to be 100, and this will be plus 450, so this is 550 kilometers. Okay. Oh, careful. I didn't copy the negative. 350. Part B. How far does it travel during the second 10 minutes? Aha. So in part B, we are asked to find the integral from 10 to 20 from v of t dt. And that will be the integral from 10 to 20 from -0.3 t squared plus 9t dt. But I already have the answer here, which was -0.1 t to the third plus 4.5 t squared. But now I have the integral from 10 to 20. I'll stop here for 1 second because I want to mention something. This is another property that I will mention again in the next few minutes. The integral from 0 to 20 from v of t dt is the same with the integral from 0 to 10 from v of t dt, plus the integral from 10 to 20 from v of t dt. Also, because I want to determine this, I can determine this and subtract the number that I already got. So why would I ever want to do that? Because it's always easier to determine a definite integral if the lower limit is 0 versus lower limit 10, upper limit 20. So I could determine this integral, which is this, by subtracting. So the integral from 10 to 20 v of t dt is the same with the integral from 0 to 20 v of t dt minus what we determined in part A. It doesn't matter how you want to proceed. They will give us the same answer. So let's say we continue here, or we want to determine this. It doesn't matter. Okay, so I plug in 20, negative 0.1 times 20 cubed plus 4.5 times 20 squared. Careful now, minus when I plug in 10. So negative 0.1 times 10 to the third plus 4.5 times 10 squared, which is basically the same thing I just obtained. So this piece is anyway is 350. So I only need to determine this one and subtract 350 from it. Same thing, exactly like we could have determined just this and subtract. Okay. So negative 0.1 multiplied by 20 to the third power plus 4.5 multiplied by 400. Okay, did I put in everything correctly? Hopefully. And then minus 350, and I get 650. This is one of the other property of one of the properties of the definite integral. We already looked at two. This is the first one. The integral from 1 to 2 is the same with negative the integral from 2 to 1 from f of x dx. And this is the second property that says that the integral from a to b is the same with the integral from a to c plus the integral from c to b. So since I'm here and I'm going to write it for you in general, this is the situation. If this is a function, and I have here a, and here b, and here c, the integral from a to c from f of x dx is the sum of two integrals. So all this area is the sum of the integral from a to b, of course from f of x dx, and the integral from b to c. Notice that these have to be the same from f of x dx. So this is property 2 of definite integrals. Okay, so since we're here, let's continue with other properties. So this is 4.4, properties of definite integrals. Okay.